Hello, 8th graders, it's Mrs. Thompson, and today we're going to talk about some special systems of linear equations in section 5.4. And our goal today is to not only solve these systems, but classify them as well. So we're actually going to add a little something that you're not used to just yet. So the idea with a special system, all the ones we've done so far in section 5.1, 5.2, and 5.3, all of those lines crisscross and they cross over at one point of intersection. Okay, that's all we've seen so far. But did you know that you could have some special systems where you could have lines that never crisscross and so you don't have a solution, or you have a situation where you have a line graphed on top of itself and therefore you have infinite solutions? Okay? These are the special situations that we're talking about. This is special. This is something you haven't seen yet. You've never seen a system show up and be a no solution or an infinite solution. Okay? So that's what we're going to investigate today. And we're actually going to start with example 1, and we're going to do systems with no solution. I'll show you what that looks like and how it would look on a graph, and show you some strategies for solving. Okay? All right, let's get started with the vocabulary. A consistent system, you've got a system with one or more solutions right here, okay? An inconsistent system has no solutions. And that's what we're going to focus on today. Systems with no solutions are going to be classified as inconsistent. But the answer, the solution, is no solution. Let me show you what this system looks like. Here's a great example right here. Okay, y equals x minus 1 and negative x plus y equals 2. Now let's look at strategy 1. Okay, I gave you 3 strategies to solve this type of system. You could compare the m, which is slope, and the b's. So let's kind of put these side by side so we can take a look at it. Okay. The first one is in the perfect form. That's slope-intercept form. Y equals mx plus b, where your m is an understood 1. That's the number directly in front of the x. And your b is the number that follows your x. And b in this one is negative 1. So there's information that we need. We need to know the m. We need to know the b. We got it in the first one. Second one, that's standard form. That's ax plus by equals c. That particular form doesn't tell us what we need to know in order to compare to the other slope and intercept. So we're going to have to do a little bit of rearranging. So I'm going to move this x over. Okay, and I've got y equals x plus 2. So this has a slope of 1. That's an understood 1 in front of our x. And the y-intercept is at positive 2. Okay? Now, think with me just a second. We have the same slope, but different y-intercepts. What kinds of lines have the same slope, but different y-intercepts? That's the situation. Let me write that out as you're thinking. Same slope, but different y-intercept. Okay, do you remember what kind of lines those are? If you were thinking parallel, you're exactly right. Okay, well, parallel lines, do they ever crisscross at any point in time? Either direction, will they ever touch each other or cross each other? And the answer is no. Parallel lines will never intersect. So write that down, never intersects. Okay? So what that tells you as the student is, well, if they never intersect, then there's no solution. So this is no solution for that answer. Okay? And that's my shorthand, and if you want to write that on future papers, you can. And for future problems, you can use that. You don't actually have to write out the whole word solution. Just write no and then the apostrophe right after the L. Okay? So that's strategy 1. The important thing that we're trying to use, what we're trying to see is if they have the same slope but different y-intercepts, they are parallel lines. That means they never intersect, and we're going to end up having a situation where since they don't intersect, that means there's no solution. Okay? Now your second strategy is you could graph it. I am not going to take the time today to graph it, but you can. We've turned them into slope-intercept form. So you start here with -1 on the y-axis, and then you're going to go up 1, right 1, or down 1, left 1. And you can graph it and see what that looks like. Come and do the same thing with this one. Graph the second line at +2 and go up 1, right 1, or left 1, down 1. And you'll see that on the graph that they actually are not going to intersect. So yeah, that's an option. So strategy 2, this is your second strategy or a strategy. They're not in order of importance, so I don't want you to think, oh, graphing should be my second option if I don't do the first option. That's not necessarily true. All right, let's look at this last option, solving algebraically. You spent the last 2 sections learning how to solve algebraically without graphing. That's using either elimination or you can use substitution. Now for this one, what I would do for this strategy is, let's see, we already rearranged it in strategy 1, so let's take the rearranged view, okay? So that's the standard form, -x plus y equals 2. That's the rearranged form of it, y equals x plus 2. And remember what I said when we studied substitution. If x minus 1 equals y, and x plus 2 also equals y, then what I have circled, they must equal each other. They must. And they do. So we're going to use substitution, and what you'll notice is you're going to take away x, and hey, they both disappeared. Look, they both cancel out, leaving me with -1 equals +2. So this is where you ask yourself a question. Does -1 equal +2? Well, no, it does not. That's not true. So that means we have no solution. Now, we've seen this before in solving equations. Remember when we solved equations before, if we lose our variable and the end result is not true, that's our end result, we have no variable, it's not true, then it's no solution. If it is true, then it's all solutions, all real numbers, infinite solutions, however you want to say that. Okay? So I'm showing you 3 strategies, talked about one of them, showed you 2 of the 3 strategies, and this is, you choose one of them to make your determination that this is a no solution. Okay? If you see the same slope, different y-intercepts, those are parallel lines, that means they never intersect, this is no solution. Or you solve algebraically, maybe you substituted, you get to the bottom line, I lost my variable, but the statement is not true, then it's no solution. Okay? If you have any questions, write those down in the margin and bring them to class tomorrow. Thanks for listening.